In section 2.1, we're talking about the rectangular coordinate system and the graphs. So in a rectangular or a Cartesian coordinate system, what you have is this grid system, and it's in a two-dimensional plane with perpendicular axis. Perpendicular axis means that they make 90 degrees with each other. So this would be 90 degrees here, 90 degrees here, 90 degrees here, 90 degrees here. And when you have 90 degrees, you put this little rectangular box to signify that it's 90 degrees. Now your horizontal axis, this right here, this is what you call the x-axis. And the vertical axis is what you call the y-axis. Now this is divided into 4 quadrants or 4 planes. Start here, quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. Now in this coordinate system, any point, say if I put a point right here, what we say is this is point x, comma, y. X always goes first, y always goes second. And what we call this right here, it's an ordered pair. Okay, now for the first quadrant, so anything in this quadrant right here, your x value will be positive and your y value will be positive. Because from right here over, this is the positive x values. From here up, this is the positive y values. Whereas over here, these are the negative x values. And down here, these are the negative y values. So if I have a point in quadrant 2, this will be negative for the x and positive for the y. In quadrant 3, we'll have a negative x and we'll have a negative y. And for quadrant 4, we will have a positive x and a negative y. These will always be the case within these quadrants. Okay, now where these two axes meet, right here, this is what is called the origin. Okay, so we go back to our point, get rid of all of this. Look at this point right here. We'll call it x, call it y. That means that we have gone over a distance of x and then gone up a distance of y to get to that point. Okay, so if we plot these points here, -4, 2. Okay, well, -4, so that's my x value. 2 is my y value. X is negative, so I'll be over here. And y is positive, so I'll be over here. So I'll be in quadrant 2 for this point. Okay, so I'm going to go over to -4 for my x values, -4. And I'm going to go up 2 for my y's. So there's my point right there. Okay, and then, by the way, for the origin, it has the order pair 0, 0. And anytime I am on the x-axis, that means that y is going to be 0. Anytime I'm on the y-axis, that means that x is going to be 0. Okay, so if we look at 0, 3, so my x value is 0, which means I'm going to be somewhere on the y-axis. Okay, so x is 0, and then I'm going to go up 3. So there's my point right there. Okay, -2, 0. Okay, so now my y is 0, so I'll be on the x-axis. So I'm going to go over 2, and then there's my point. -1, -3. Okay, I'm going to go over -1 and then down -3. There's that point. 2, 2. I'm going to go over 2, up 2, right there. And then 3, -1, so go over 3 down 1. And there's all your points. Now, let's try to graph an equation by plotting points. So the first thing that we would do is make a t-table. So something like this. And I'd have a column for my x values and a column for my y values. Or whatever your y value is equal to. Say it's 1/2 x plus 5. You could write that as well. It's easier just to write y though. Okay, and then usually we choose the x values, and you want to choose x values that make the algebra as simple as possible. And then so usually you choose -2, -1, 0, 1, and 2. Those are just the go-tos. And then for every x value within your equation, you're going to plug these x values into that equation and get your y values. So you put your y values on this side, and then you would plot those ordered points. So for like this one, graph the equation y equals 1/2 x plus 2. So I'm going to go ahead and get my t-table. I'll do -2, -1, 0, 1, and 2. And then to the side, I'm going to plug in, so for x equal to -2, y is equal to 1/2 times -2 plus 2. So I can write this over 1. I have a 2 on top, 2 on bottom. They cancel out. And I have -1 plus 2. So y equals 1. So there's my first order pair. And then if we keep going, y equals -1. X equals -1. Y equals 1/2 times -1 plus 2. So y equals -1/2 plus 2. So then I'm going to rewrite 2 over 1. I need to get the denominators the same. So I'll multiply this by 2 over 2. So this will give me y is equal to -1/2 plus 4 over 2. And now they're the same. So I can put them over. And let me come back up here. Y equals -1/2 plus 4 over 2. So y equals -1 plus 4 all over 2. Y equals, let's see, 3 over 2, which if you plug this into the calculator, this is 1.5. So we'll put 1.5. Okay, for x equal to 0. So y is equal to 1/2 times 0 plus 2. Okay, 0 times anything, we'll just wipe that entire thing. That'll be 0. So I have 0 plus 2, or 2. Okay, for x equal to 1, y is equal to 1/2 times 1 plus 2. So y is equal to 1/2 plus 2. Same thing, I'm going to put this over 1. Multiply it by 2 over 2 to get the denominators to the same number. So 1/2 plus 4 over 2. So this will be 1 plus 4 all over 2. So this will be 5 over 2. Now if you plug this into your calculator, 5 divided by 2 is the same thing as 2.5. So 2.5. And then last but not least, we'll do x is equal to 2. So y is equal to 1/2 times 2, times 2 plus 2. So put this over 1, my 2's will cancel out, and I get 1 plus 2, or 3. Okay, so now what my order pairs are, you can make another column over here. So my x, y order pairs will be -2, 1, -1, 1.5, 0, 2, 1, 2.5, and 2, 3. So then I'll go to my graph and plot each of these points. So -2, 1, -2, 1, -1, 1.5, so -1, 1.5, so halfway between those two. 0, 2, 1, 2.5, so about there, and then 2, 3. Okay, and then connect those dots with a straight line. And then there's your graph of y equals 1/2 x plus 2. Now the reason I know that this is going to be a straight line is if you look at this function right here, and then look at your x. It's really raised to nothing, but it's understood to be raised to the power of 1. So if x is raised to a power of 1, or if you don't see a number, x raised to a number, then you know that this is going to be a straight line. Whereas we'll get into later, if we see x, say squared, that's going to look like a parabola, which would not be a straight line. Okay, so what we're going to do now is, let me get rid of this. We're going to complete this table using this equation, and they give us x values to plug in. So we'll just take 3y plus 4x, and I'm going to use this -2, is equal to 12, and then I'm going to solve for y. So this is going to be 3y minus 8 is equal to 12. Add 8 to both sides. So 3y is equal to 20, and then divide both sides by 3. So y is equal to 20 divided by 3. Okay, then I'll put that here. And I can't reduce that, so I leave that as 20 divided by 3. And then we'll use 3y plus 4 times -1 is equal to 12. So 3y minus 4 is equal to 12. Add 4 to both sides. So 3y is equal to 16. Divide both sides by 3. So y is equal to 16 over 3. And I can't reduce that either, so I'll leave that as 16 over 3. Okay, so now 3y plus 4 times 0 is equal to 12. Okay, that's just going to go to 0. So I have 3y is equal to 12. Divide both sides by 3. So y is equal to 4. Okay, 3y plus 4 times 1 is equal to 12. So 3y plus 4 is equal to 12. Subtract 4 from both sides. So 3y is equal to 8. Divide both sides by 3. So y is equal to 8 over 3. And again, I can't reduce that, so I'm going to leave that as 8 over 3. And last one, 3y plus 4 times 2 is equal to 12. So 3y plus 8 is equal to 12. Subtract both sides by 8. So 3y is equal to 4. Divide both sides by 3. So y is equal to 4 divided by 3. And I can't reduce that any further, so that will be 4 divided by 3. And then there's my table. Okay, now let's look at trying to find x-intercepts and y-intercepts. Now an intercept of a graph is where the graph crosses the axis. And it says that right here. It'll cross one of the axes. So if I have, here's my x-axis and here's my y-axis. If I have a graph that crosses my y-axis, then right here at this point, I have a y-intercept. If I have a graph that crosses my x-axis, then right here at this point, I have an x-intercept. Okay, well, at this point right here, on the y-intercept, we know that x is equal to 0. So right there, if I have a y-intercept, then x is going to be 0. Right here at this point, on my x-axis, we know that y is equal to 0. X-intercept, y is equal to 0. This will always be the case. Okay, so if we find the intercepts for this equation, y equals -3/4 x plus 3. So say we find the x-intercept first, which means that y is equal to 0. So what I'm going to do is I'm going to replace y with 0.